Okay, thank you, Xinwei. And yeah, please raise your hand to ask questions live. And I've seen Chirag asking a question. Here, Chirag, can you unmute and put on video?
Can I go ahead?
Yeah, you can go ahead.
Yeah. Hi, thanks for the talk. So I had a question about your key idea one, right? Where you said, if I write if key equal to something and if token equal to something, and then I change, then I infer that. But a programmer could have written in a different logic, right? Wherein it says, if the key is false, then I'm changing, in which case you would want to update the key first and then make the changes to the values. Is it making sense? Like,
yes.
What I mean is, if you say if token and then give a condition, doesn't necessarily mean that it has to be persisted before the values being changed.
Yeah. So in the example, we are if and then we are read. So which means when that one is ready, when the token is ready, and then you are reading something, then that one is ready. And in your example, you are saying if something equals to false, and you are writing. So
Yes.
there are details of the happen before order in the paper. So we treat this read and write differently. So there we can talk about the offline about the details.
Okay.
Yep.
So what you're telling is it's not just if and else, there is more.
Yes,
more.
yes, yes,
okay.
More. Yeah.
Got it. Yeah. Thank you.
Okay, next we see a question on Slack and by Ian Neal. Ian, would you also like to ask the question live?
Sure. Can you hear me?
Yes, yes.
Hey, thanks for the presentation. I just had a couple questions. One of them is that you guys report a lot of performance bugs, and I was curious how many of what's the impact of these performance bugs? In my experience, a lot of these performance bugs can be like a single additional flush or fence, which over like the course of the entire application may not have a noticeable impact. And in some cases, if you remove them arbitrarily, you can actually impact the correctness of unobserved program executions. So that was my first question. I had a couple others, but I can wait to ask those in a second.
So your question is the impact of the performance bug? Yeah, we don't measure the impact of performance bug as we mentioned in the presentation. Since we have the trace, we should detecting this performance bug as a bonus here, and those conditions for detecting performance bugs and those ideas are not new, are based on previous work. So we treat this as a bonus because we have the trace, so we can detect them.
Okay. The second question I had was, can you talk about when Witcher might have any potential false negatives? So like, are there certain patterns of bugs that Witcher might not actually be able to detect, or are these things that you've observed?
Yeah, good question. So this is a dynamic tool, so it's not guaranteed it can detect all. So first thing is to detect depend on the test case whether you can review the bug. Second, if our rules didn't capture any bug pattern, it may also miss any bugs. But due to we don't have a complete set of bugs we know, but what we know is that for the cracking bug, we detect all the bugs detected by other tools. So that was my answer. Did I answer your question?
Yeah, and then just real quick, because I know a couple of people have some other questions, was how much work does it take to apply Witcher to other key value stores? So like, do you have to write an API to exercise these key value operations for other like different key value APIs?
Yeah, good question. So we provide a driver so you can put your operations there. So the key here I want to emphasize that is we don't need to explicitly to require the operation return any value, because we just compare the output for two oracles. So you can return any value for your API. What you need to do is just put that API to our driver. So that's it. So it will be not a lot of manual work.
Thank you.
Okay, so we have time for one more question. And then for Miguel and Rohan, and we'll postpone the question to the mini panel session at the end of this session. So next, Shanlu, would you like to ask your questions?
Oh, I have a very quick question. So on slide 6, you have the example of if token something, key something, and then you do something to the value. And you mentioned that you can infer that token should be flushed before, right? Key and value. But then I wonder, why don't you infer that key should be flushed also before value? Because key is also a control predicate.
Yeah. That's a good question. Thank you, Dr. Lu. So I just read your question from the Q&A. So there are two control dependencies here. Token read key is dependent on the token, and the read value dependent on the key. And you are talking about why didn't we infer happen before the between key and the value? Yes, we also infer that. So that would be happen before the we inferred, and we will not. And then when we have a variation, we will also test it, and we found out that this will not trigger a bug. So that's why we called this is likely correctness condition. We didn't say this is always true. Once we found it, we have the second step to test it. Once it reveal our inconsistency, we will report it. So it doesn't need to be this likely correctness condition to be true. It's just likely to be true. Then we test it. Did I answer your question?
Okay, I will follow up later. I mean, what do you define consistency? But I will check. Check.
Sure. Thank you. Sure. Thank you.
Okay, now we are ready for our second paper, understanding and detecting software upgrade failures in distributed systems.
Camera and microphone for questions. So any questions? Okay. Jiahuan Shen.
Hello, can you hear me?
Yes.
Hello, I'm Jiahuan Shen from Shanghai Jiaotong University, and this is a very interesting work. And my question is that whether your solution can find the performance bugs, as if I think the performance bugs will not violate the correctness condition. Thank you.
Using the your understanding is correct first, and thank you for your question. So using that two key ideas is the key ideas for finding the correctness bug. But for the performance bug, because the correctness condition is very universal and simple, it's just like extra flush or extra fence. And as we presented in the talk, so since we have the trace, we have the full trace of the execution. The trace have the store and the fence and the flush for inside this execution. What we need to do is just simply scan the trace, then we can find the performance bug along within this execution. So we treat this as a bonus because the conditions for finding performance bug is already defined in previous work. So that's why we treat that as a bonus part, not a focus of this talk. I hope this answers your questions.
Okay, thank you.
Chen Yang. Yang, you can speak. You can turn your microphone and ask your questions.
Oh, hello. Can you hear me? Hello? Can you hear me?
Yeah, you can ask your question.
I am from Shanghai Jiaotong University, and it's a great talk. My question is, you have mentioned that there are two types of correctness bugs. One is consistency bug, and another is atomicity bug. But I don't understand that is the hints in the program how can it also hint the atomicity bug? For example, the A and B must be both things to the memory or nothing at all. I think the consistency is very straightforward to be seen in the program, but automatically maybe not. So that's my I don't understand it. Can you illustrate it a bit more?
So I didn't capture the whole. Can you repeat your question simply again, please?
Oh, I'm sorry. My question is that I think persistent bugs, the sequence of A and B can be seen very straightforward by the hints in the program, as you have mentioned in your talk. But atomicity bugs, I think it's not very straightforward to be seen in the program. Whether the A and B should have an atomicity property. So how can your work detect it? Or how do you deal with it?
Yeah. So your question is that how can we detect the atomicity bug, the persistent atomicity bug, right? Okay. So it is not described in the short video, but it will be described in the full video. You can read that, watch that, and also in the paper, there are details there. I will show the idea here. So the key idea is that the pattern we capture, like in the example we presented, like it uses a token. It uses a token to tell the reader side when the token is persisted, key and value is persisted. This is one way to guarantee the persistent, to guarantee the atomicity. You have a durable, you have a linearizing point, and to tell the program which one is ready. So we will treat this token as a guardian. So if you want to update two key value pairs atomicity, then you have to persist the two tokens atomicity. So this will be one pattern we detected in our work. So maybe it's not that in details, but I think we can talk in offline about this question, because the talk doesn't focus on this one yet.
Oh, I understand. I think I can see your paper and the long talks later, and
okay.
Thank you. Thank you.
Okay. Thank you.
So next question, I think Yichun Yang. I think you are already in the panel.
Hello, can you hear me?
Yes.
I am Yichun from Shanghai Jiao Tong University. Sorry, I don't have a camera in my laptop. And first, thanks for your great talk. My question is that in your likely correctness conditions part, so why don't we test the case that only the token and value are persisted, but the key is not? I think it may also cause a mistake. And in fact, I am also curious about how you enumerate the crash state. That's my question. Thank you.
Okay, good question. Thank you for your question. So yes, you persist the token and the value together, it will also incur the problem. But it is already covered by we only persist the token. So we will not enumerate in this case. So we will only eliminate the cases that are violating our likely correctness condition, which we inferred from using the control dependence in that example. Like we have a control dependence between token and the value, and which means when you read the key, when you read the token, when the token is ready, key and the value must be ready. Then we will do that in adversary manner, that we persist the token and to see what will happen. And so how we enumerate the rule is that we only enumerate the state that violating our inferred rule. So I hope I answered your question.
Okay, I got it. Thank you.
Because of the time limited, so I think the other questions can be saved to the mini panel session after all talks. This concludes this talk. Thanks, Xinwei.
Thank you.
Yeah, thanks, Xinwei. Let's move to the next talk. Next up, Professor Yongle Zhang from Purdue University is actually going to present a paper on understanding